Hi, welcome to Calculus again. Today we're going to be looking at finding arc lengths of curves. Okay, so this is for any curve from A to B, and we're going to try and figure out how long that curve is. So to do that, basically what it boils down to is we're using a distance formula. But of course we're using a distance formula and then throwing calculus on top of it. So if you remember your basic distance formula, it's just that the distance is equal to the square root of the difference in the y's squared plus the differences in the x's squared. And so what we're going to do with a little bit of calculus and a little bit of work, you can partition your axis up into segments and find those little line segments. When all is said and done, we get this formula that the length of a curve is equal to the integral from a to b of the square root of 1 plus the derivative of f squared dx. And we're just going to start applying this, and we're going to find some curve lengths. So let's get started. Find the length of the curve, y equal to x to the 3 halves minus 4, where x is between 1 and 5. So I started by finding the derivative, because I need the derivative in order to work with this, to find this length. And the derivative, I dropped the 3 halves, subtracted 1, so I got 3 halves x to the half. And because in the formula it's got a square on that derivative, I then just squared it, which gave me 9/4 x. So I did all this work to prep myself now to find this arc length. I have the integral from 1 to 5 of the square root of 1 plus 9/4 x, because again, there is a 1 over here in the formula, don't forget that. And so then I integrated it. So first I changed the square root to a half power because that's just much easier. And then I raised the power by 1, which gave me 3 halves. I multiplied by its reciprocal, and I did have a little teeny chain rule here inside, so I had to multiply by the reciprocal of that 9/4 as well. So all told, I get 8 over 27 times 1 plus 9/4 x, all raised to the 3 halves power, evaluated from 1 to 5. And you can see here I plugged in 1 and 5 and started to clean it up. And right about here, I had 8 over 27 times 49 over 4 to the 3 halves minus 13 over 4 to the 3 halves. Right about here, I realized it's going to be ugly because there's nothing nice that's going to happen with that 13. And I put it in my calculator, and hopefully you can see it, but I got 10.97. So that's our first example. I'm going to do one more. Let me rewrite the board.